Hello everyone. I'm going to do an example of using the law of cosines to solve a triangle when all three sides are given. So I know all three sides of this triangle, so this is that side, side, side situation. So I can use the law of cosines as a way to start, and I can find one of our missing angles. So if I jot down the law of cosines again, minus 2ab cosine of c. The important thing about the law of cosines is just that the angle that I'm given, or the angle that I want to find in this case, this has to match up with the side length that is across from that. So let's say I want to find the measure of angle x. So let's start here. So that means x is going to go in for c, capital C there, and then the side length that's across from this, the 45, that needs to be the one that's all by itself on this side of the equal sign. So we'll put 45 in there. The other two sides, these would be a and b, and they are interchangeable. So 38 squared plus 51 squared minus 2 times 38 times 51, and then the cosine of x. So we do know that I want to find an angle measure. So because of that, at some point I'm going to have to use the inverse cosine to find x. Before we can do that though, we need to isolate the cosine of x. So I'm going to do a little bit of simplifying. I'm going to move everything over to the other side so we can take the inverse. So 45 squared, 2025, 38 squared, 1444, and 51 squared is 2601. And then doing this multiplication, 2 times 38 times 51, we get 3876 times the cosine of x. Okay. Let's combine some like terms here. So if I add 1144 plus 2601, 4045, okay. Now I am trying to isolate the cosine of x, so I'm thinking kind of backwards here. So first I am going to subtract the 4045 from both sides. You get negative 2020, and that is equal to negative 3876 times the cosine of x. These are being multiplied. So to isolate, let's divide both sides by the negative 3876. We have a negative divided by a negative, so those will cancel out, turning it into a positive. So we end up with the cosine of x is equal to this fraction 2020 divided by 3876. Alright, so now that we isolated the cosine of x, we know that the cosine is equal to this ratio. So the inverse cosine of this fraction should give me my angle measure. So the measure of angle x, the inverse cosine of this fraction. And then typing that in, let's see what we get. So the inverse cosine, 2020 divided by 3876. We get about 58.6. Okay. So now that I know one of the angles, I know x is about 58.6. I could use the law of cosines to find a second angle, but I can also use the law of sines. So now I know an angle, I know the side across from that, and then I could use the law of sines to find another angle because I know the side across from that one. So the sine of an angle, the side across from that one, is equal to the sine of another angle, and the side across from that. So the sine of 58.6, the side across from that is the 45, and then we'll set that equal to the sine of y, which is the one we'll find, and the side across from that is 51. So multiplying both sides by 51 to isolate the sine of y, and then taking the inverse sine of both sides, that is going to give us the measure of angle y. So the inverse sine of this entire fraction so let's see what we end up with. So the inverse sine, 51 times the sine of 58.6, close my parentheses there, divided by 45, and we'll close our last one. So we get an angle of about 75.3 degrees. And now that I know 2, I can find our last one, so the measure of angle Z, using the triangle sum theorem, 180 minus the other 2. So 180 minus 58.6 minus 75.3. So our last angle, about 46.1. Okay. Now we can check out, see if these answers make sense. If we look at our original triangle, the side that's across from the Z, that was the smallest side, so that should be the smallest angle, which it did end up being. Across from Y, that's the biggest side, so this should be the biggest angle, 75.3, which it is. So there's an example of how to use the law of cosines to solve the side-side-side case.